Hi everyone, my name is Adam, aka Adam Tilted. This is Orbit at a Tilt. Hyperjetty, thank you for joining. I am going to copy the link into the comments. Hyperjetty, if you want to come on, that would be great. Hi, Bree. Thank you. That music is by Glitch Nemesis, who is my nephew, Simon. Hi, Simon. And I put a link to his Patreon account on my timeline, so go check that out. Tonight, we are going to talk about Uranus. Uranus has been that planet that makes us giggle, right? Because, do you pronounce it Uranus? Uranus? I pronounce it Uranus. You can pronounce it however you like. But go ahead and get the giggles out. That's what I would tell my students. Go ahead and get the giggles out because we're going to talk about Uranus or Uranus. Thanks for joining. We have got a great audience. I am looking forward to exploring this crazy planetary system with you. First, I want to show you something that I think is pretty cool. This is an image that I took using a remote controlled telescope in Chile, I believe. I want to say it was Chile. I don't remember. Oh, yep. Oh, no, this was in the Canary Islands. The Canary Islands. This is the fireworks galaxy. So I chose that since we are celebrating Independence Day in the United States. And I've got my flag outfit on. Fireworks galaxy. Happy birthday, America. Okay. We're going to be talking about Uranus, and note that there is a delay of a good 8 to 10 seconds between what I say and when you see it on Facebook and when you comment and I see it on what I'm looking at. So consider that while we are interacting. What I'm going to do to accommodate that is I'll ask a question and then I'll talk and then, see what answers come up. One other thing I want to show you, let me see if I can find this one. Okay, this is cool too. This is an animated GIF that I made, and that is Uranus. I used images that I took from, this one was from Chile, I believe, of Uranus over several days using SLU. SLU.com is one of the remote telescope services that are available. Yeah, okay. Yeah, Danica, it may not be mature enough for this. That's true, but we'll give her the benefit of the doubt. I really love making these kinds of animations, especially in real time. That is from 2015, I believe. So if you would be interested in helping me get access to that, me by becoming a sponsor of the show at patreon.com/AdamTilted. And I'm going to put that in the comments. And seriously, any little bit makes a difference. Even if you just do $1, it makes a difference. Because it does cost money for me to produce this show, and I won't be able to continue to do it without your support. So that's one way that you can support me. Another way is if you could share this out, that would be awesome. Share this out to your timelines. Maybe tag some friends who you think might be interested in learning about space and science and our solar system. Let's jump right into the solar system. Now let me, hold on, I've got too many of these things up on my screen. Okay, so here we are with the solar system. Hold on. Great. Uranus. Before I zoom in on Uranus, I do want us to take a look at some of the information over here because I have to sort of tell on myself. I had done a lot of research and planned out, what I was going to say, and about 10 minutes ago, I realized that I couldn't find my notes. I don't know where they are. So I'm winging it. And I also realized that when I went back to try to recreate my notes, that the reason why I chose Uranus was based on something that's happening on the calendar, but I was using the wrong month. So it's probably good that I lost those notes. So I am kind of winging it with Uranus. So we're going to just see what Solar System Scope has to offer us. I have a basic idea of what we're going to find. And if anybody wants to come on and be my guest host, that would be great. It's much more fun for me if I have a guest. So the comment is out there. The link is out there. I will put it out there again. I can't pin it from how I'm doing it. But if someone else out there has that capability and can pin it, that would be great. Uranus. Now, I'm not sure how much you can see this, and I don't know if there's a way for me to zoom in. So, okay, great, Brigetti. So I'm going to be reading some of what's on the screen, but not all of it. And if you want to know more, or if you notice something on the screen that I didn't talk about, but you want to know more, put it in the comments, and I can always come back to it. This image that we have of Uranus is from Voyager 2. That is the last and I think only spacecraft to visit Uranus. Voyager 1 may have done a flyby. I can't remember. And that was over 30 years ago. Uranus was the first planet to be discovered using the modern telescope. That's interesting. So Uranus is the 7th planet out from the sun, and it is a gas giant, not as big as Saturn, but similar in size to Neptune. And here we can see the system. And let's move this ahead. This is moving about an hour a second. Okay, can you see me down here in the corner? Hi. This is moving at about an hour a second. And if you consider how big Uranus is, Puck here is hauling butt. Okay? You would be able, if you were on Uranus, at least at the cloud top level, you would be able to notice it moving across the sky. Now, the other thing that's really strange is that Uranus has a severe tilt of almost 90 degrees. So it looks like it's rolling on its side instead of our orbit, which let me just show you as comparison. Let's look at Saturn's orbit just for comparison. Because Saturn has a lot of moons. You see the tilt here, okay? That is similar to the tilt that we have on Earth. It's about between 20 to 30 degree tilt. Saturn may be a little bit more, I don't know for sure. But Uranus is crazy town. Like, it's on its side. And how did it get that way? We don't know. Now, it does have all of its moons going in the same direction. So it does have that going for it over Neptune. And it does have the same blue color as Neptune, which is caused by the methane gas absorbing the red wavelengths of light that comes from the sun. All right, so let's look at Uranus itself and the structure. So inside, at the very inside of Uranus, there is a core of solid silicate and iron nickel rock, we believe, which is surrounded by a hot ocean, okay, made up of water, ammonia, and methane ices. But they're not really ice, if frozen in this case. They're actually above the freezing point, but because of the pressure involved, they don't behave like regular water. So they behave like an ice, but they are acting like a liquid. Okay? So yeah, there's a lot of methane in the solar system for sure. And then around that mantle is the atmosphere, which is made up of hydrogen gas, helium, and methane. And that atmosphere gradually transitions into that liquid ocean layer. Because it has a solid nickel and silicate core, it has a pretty significant magnetic field, because that is caused by the motion around that. And I just uncovered in the lobby and realized that I have some people in. So I'm going to bring in Brigetti first. Welcome, Brigetti.
Hey, Adam.
Hi, how are you?
Hi. Good, and yourself?
I am good. I think I might be getting a little feedback in just a second when the delay goes by. But can you guys still hear me that are out there? Bree, if you're still out there and you can hear me, then let me know. Brigetti, you can hear me, right?
Yes, I can.
Okay, great. Okay, so did you have something you wanted to talk about Uranus?
I'm enjoying this. I didn't know anything about Uranus. In fact, I didn't even know how to pronounce it,
Mm-hmm. Well, it's there's a whole story. Thank you, Bree. There's a whole story behind the name, because I think its name was originally going to be George.
Oh, really?
Yes, named after the king. But I don't want to go too much into that because I lost my notes and I don't want to, put out misinformation. So when I find my notes or when I have time to go back and look, I will post a little update on my YouTube channel, which, by the way, could use some subscribers. Really, guys, I need your help because I need a custom URL. You're going to see in just a minute. This URL is crazy. No one's going to be able to find me. But I can't get a custom URL until I have 100 subscribers. And right now I only have 39. So spread the word, tell everyone, just subscribe. I put out content about twice a week. So you're not going to get spammed with a whole bunch of stuff. And it's good content, I think.
Yes, your content is very good.
Thank you.
I have gone and subscribed to your YouTube channel.
Thank you.
So that's done and dusted for me. Pleasure. And I'm happy to share that. Your content is great.
Thank you.
Very informative. And I really do enjoy the way that you present the content. I do.
I appreciate that. Good. Well, my goal is to make space and science understandable to people and not intimidating, because a lot of people unfortunately have had negative experiences with science in school, and so they feel a little intimidated about it. But I want to give another perspective on that, so I'm glad I'm having that impact.
Well, that was me at school. I felt intimidated back in the day. And to be honest, this has been my first experience watching you, and I'm having so much fun. I'm learning a lot from you, and if I could go back to school, yay! If I had a science teacher like you, I'd be acing it.
Well, the good news is there's more to come, so stay tuned. I also made a Facebook page. I feel like I'm doing a little promotion, but just right here in the middle, and then I'll stop. There is a Facebook page for the show, Orbit at a Tilt, and after the show, I will put that down there. You can like the show page, and that is the best way for you to get notified of when new shows are coming. Typically, I'm on 5:30 p.m. Central Time on Mondays. I will do occasional updates if exciting things are happening, like this coming, hold on, what is it, Saturday? No. Thursday, this coming Thursday, July 6th. So I want to show you that. And then we're going to come back to Uranus for a second, because there's a lot more to know about Uranus. But I want to show you this first. And I'm going to set the time to July 6th. And we'll go forward in time to about 9 p.m. And I'm going to move above the horizon and find the moon. So I'm going to look over. The moon will be over here towards the southwest. There it is. I mean the southeast, sorry. In the southeast, there's the moon. And just right next to the moon will be Saturn. This is on Saturday, so at approximately a few minutes after, well, as soon as you can see the moon rising, which should be just a little while after sunset. Now for Brigetti, you in the southern hemisphere, this is going to come around for you in the morning before, because you're going to get to Thursday. So for you, it's Thursday morning, but for you, that will be yes. Wait.
So Adam, is this the software you're using? Morning. Is that real time?
I can set the time to whatever I want. So right now I have it set. That's the cool thing about that. This is called Solar System Scope. I have another one called Stellarium, and I'm going to show you that one as well. The Solar System Scope also has an online version. So if you don't want to download the software, there's a free online web version that you can do with that. It does pretty much everything. But you can move time forwards and backwards, and you can follow certain objects through the sky. So it's very helpful to look ahead, to help look ahead and see what's coming, like these alignments. Because this one it will be the previous morning for you.
Right.
And the evening for me will be the Moon, Saturn, and Antares, which is one of the brightest stars in the constellation Scorpius. Okay. And I'm gonna come back to that in just a minute. And I'm going to bring in Danica. And I'm going to give Danica a few minutes to chomp down her food. Okay, Danica, you ready? Okay, here we go. Danica is coming in, so that will be fun. Okay, Danica. Hello, Danica.
Mm-hmm.
Okay, here we go. Danica.
Hey, Danica.
Hey, I'm just bear with me. Let me swallow.
Yeah. I figured my only chance to get you on here without you talking was to have your mouth full. or mute you. I guess I could do that, but I wouldn't do that.
Okay, Adam, I cannot hear you. I can only see Brigetti, and I can't see you or hear you on the computer and my phone. There's a delay. So
that's weird. Brigetti, ideas?
It's usually the internet connection. There's no other reason for it to happen other than and it's not your download speed, it's the upload speed that plays up.
oh, my computer's doing pretty good. I just can't. Like, I have full bars, but I don't know. I can't see you.
Okay.
I'm listening to you guys on my phone, and it's a huge delay. So I'm going to back out. Great to join you, but I don't want to delay your show.
Okay, thank you.
Bye.
Okay. And I don't mind if that happens, by the way. So anybody who's watching, anytime you want to hop on, this is meant to be an interactive program. So please, give it a shot. All right. So on Thursday, keep an eye out for that pairing. It should be pretty to look at. Now let's go back to Uranus and check out this odd system. So it is rotating nearly on its side, and all of its moons are orbiting in an up and down relative to the ecliptic, rather than around and round like our moon does, right? Let's see if there's a way to.
Okay.
Can I make okay, yes, that's what I want. Okay, so that's weird. So let's look at the innermost moon, Puck. And we're going to look at the bright side. Nice, we can see Uranus in the background. If you were on Puck, what a view that would be. Hmm?
Absolutely.
So as we move time ahead, you can see that Puck, this is 37 minutes a second. This is very slow. If I did this to our moon, we wouldn't even notice the rotation yet. So this is about an hour a second, and it is spinning quite quickly, and it is orbiting Uranus very fast.
Wow.
We don't know much about this little moon. It's the largest of the small inner moons of Neptune, and it has a very dark surface. We don't know why, but it only reflects just a very small amount of the light that hits it. Miranda is the next moon out. Miranda also has a pretty rapid spin. Not quite as much as Puck, but there's Miranda at about an hour a second. And as seen from Uranus, this is what it would look like. You would see the phases of the moon in one day.
Wow.
So this is July 9th. Okay, July 10th has just started. It's still July 10th. 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 That's how fast that moon is moving around the sky. You would be able to notice that. That is amazing to me. If our moon did that, that would be crazy.
It would.
Yeah, And then here's Ariel. And you'll notice a theme with the names. Moons are named after characters from Roman and or Greek mythology that are related to who the planet is named after. So because this is Uranus, the god of the underworld, then all of these moons are characters from that are somehow related to the underworld. Interesting fact, I guess.
That is amazing.
Yeah. So just the speed and remember how large Neptune is. Neptune is not, Uranus. Wait, I went too fast. Where did it go? Uranus. Okay, Uranus is 4 times the size of Earth when you're talking about the diameter. 4 times as big around.
Wow.
So, considering that, and the fact that the moons are still able to go that far in that time, pretty crazy. Crazy. But that's why I love these outer planets. They are so mysterious. We don't have explanations for why anything about Uranus is the way it is. Why is it at such a tilt? We can imagine that it couldn't have formed that way. That doesn't make any sense because everything in the disk around the sun was going pretty much in the same direction. That's why all of the planets are tilted, but they have pretty much the same tilt within 10 degrees or so, but not Uranus.
That's weird.
Yes, and its moons also are tilted. So I'm thinking that whatever caused Uranus to tilt on its side happened before the moons formed.
It makes sense.
Because if the moons were already there and something impacted Uranus, I would expect those moons to have been lost, right, as a result of the debris of that impact. I wouldn't expect them to go back into orbit around Uranus. But I don't know. I'm not a planetary science expert. We'll have to find one that can come on the show and help us answer these questions.
That would be great.
Yes. So let me show you the other simulation software. because I really recommend that if you have any interest at all in learning about the sky, that you get some sort of software. There are apps that you can get on your phone. There, that are free or relatively inexpensive. There are these applications that I use on the computer that are a little bit more advanced, but have a lot more capabilities. And you can learn a lot from just poking around and watching time go by in these simulations. So,
it's
for
amazing
example,
what we've got access to.
Isn't it? I know. Yeah. I mean, to run this, have the capability to do something like this 20 years ago would be unthinkable.
Absolutely.
We
didn't even have access to computers back then, did we?
Exactly. No. And so the rapid access to just what is available to amateur astronomers or amateur scientists, it's out. There are resources out there, so don't let that discourage you. Now, there are some that are quite expensive, and if you stumble onto those, can scare you away. So stick with me, and I'll give you all the hints. Now, Stellarium, I think, might have a free version, and it might just be free. I can't remember. But it wasn't very much because I don't pay very much for software because I don't have very much. But the cool thing I like about Stellarium is that this is current time for me right now. So this is what it looks like outside, except that there's not an ocean. And this is looking towards the west. So I'm going to move it more towards the south and zoom it out just a little bit. I can see Saturn. The moon is right there. Generally, when you want to, when you're looking at the sky when it's getting dark, the best place to look is in the southeast, because that is where the objects are that are going to be in the part of the sky that gets dark first, just like where the moon is right now.
Right.
So as I move time forward, the sun is setting. The moon is rising in the sky. Okay, we're at twilight now. Okay, so now this is astronomical night. The sun is far enough down that it's not interfering with our view. And Jupiter and Spica, I'll put this up solo for you guys on Facebook. Jupiter and Spica right next to each other in the constellation Virgo. Very easy to spot. Very easy. And if you have a pair of binoculars, go out. And if you have a pair of binoculars and a clear night, go out and look at Jupiter and look at the moon. This is prime viewing because they're both high in the sky. They will be up for most of the night. And the moon is nearing, it's just past first quarter. So it's approaching full, but it's not there yet. And contrary to popular belief, full moon is not the best time to observe the moon.
That's interesting. I never realized that.
The reason is because the full moon is very bright when you're looking through a telescope or binoculars. And that's a good question, Bree. I don't know. We can look. I can search for it. The full moon is so bright that it washes out the details. But when the moon is such as this, and I'll solo that up for for the Facebook audience, then you can see, especially along the shadow line, the day-night line, you can make out the peaks and valleys of the craters and the details of the jagged surface of the moon, which is fascinating to see. That is one of the best parts about the moon, looking at it through a telescope or binoculars, is seeing those impact craters in such detail. It's almost shocking because we're used to seeing those on the moon, but it seems like a very flat landscape, but it is not. And so when you can catch that, when there's a day-night line on the moon, that's the best place to look, because that's where you're going to see interesting shadows that play against the sides of the craters that will allow you to see details that maybe weren't obvious before. Crescent moons are really great for the same reason. And now is a good time to go out and look at the moon. Also a good time to go out and look at Jupiter. I'm going to look for your star, Bree. Now let's see. Let me look in. Is it called Bree Palmer? No, it doesn't find Bree Palmer. If you have the coordinates, I could definitely find that. Could bring those for next time. That would be cool to see where in the sky your star was. That would be fun. So I have both programs up now, actually. I have Stellarium is... Which one? Stellarium is the one that is on the bottom, and Solar System Scope, oh, you can see the logo in the top corner, is at the top. They're both very good for very different reasons, so I can recommend either of those. Hi, Mary. I'm just looking back through the comments. I'm going to put, for fun, I'm going to put Uranus back up here so we can see it. Wait. And let you watch that instead of me. Another thing that makes this weird, because Uranus is at such an extreme tilt, that means that the front side, like the front half of Uranus, is facing the sun for a long time. Because it takes Uranus a long time to orbit the sun. Let's see how long. Its orbit around the sun is 84 times as long as ours. So it takes 84 Earth years for Uranus to go around the sun. And during a quarter of that time, one part is getting the full brunt of the sunlight for a quarter of that time, 21 years. That's a long winter on the other side. Hey, maybe that's what Game of Thrones is, because they have a long winter, right? That could explain it. Okay, so we have reached the official end of the show. The after party is happening right after, but I'm going to roll the ending credits so we know where to end the edit for YouTube. So thank you for coming and watching, learning about Uranus. If you have questions, please put them in the comments, and I may use them for an upcoming show. Also, if you have ideas for topics, put them in the comments as well, or comment on the Orbit at a Tilt Facebook page. Don't forget to subscribe to my YouTube channel. I need 100 subscribers. You could be the one that pushes me over the edge. I appreciate it. Don't forget to look up okay, so those of you that are hearing me, because that didn't go right. We're going to try it again, okay? Because I forgot that I have to change the sound output. So if you're watching and you want to you're learn from that, you got to change the sound output. And now, ready? Hit it! No, go. Okay. Excellent. Okay, that's a wrap. Thank you, everyone. Thank you to the producer, who is me. Thank you to the sound guy. That's me. Camera guy, thank you. The light, the Lumi case did a good job. I want to get a better light, though. It's balancing. I'm kind of a little nervous there. So, Bree, you still here? How'd you like it? Are there any questions? Oh, you're sweet. Great. Well, thank you for attending the live show. I really appreciate it. I know I can count on you, Bree. You rock. And thank you to everyone else, Danica, Brigetti. Who else was here? Melissa, thank you. I think I got everybody who was here for the live show. Thank you very much. And if you're watching the replay at this point, peace out.